Today we're going to learn about solving systems of equations by elimination. Well, what does elimination mean? For example, how do we eliminate the number 6 in the equation below? Well, in order to eliminate number 6 and isolate that x variable, I would have to subtract number 6 from the left-hand side. But whenever I subtract on the left-hand side, I have to do the same thing on the right-hand side. So I'm going to subtract number 6 on the left-hand side, and I'm going to subtract number 6 on the left-hand side. So what am I left with? On the left-hand side, I'm going to have x, which is now isolated, equals 5. And now we have eliminated the number and solved for the one variable in our equation. We will do something very similar with the elimination method. In our first example, we have two equations, 3x plus 2y equals 9 and 2x minus 2y equals 16. Some questions to ask whenever we are presented with a system of equations and we are asked to solve by elimination is, do the x or y variable have the same coefficient? Well, let's look at x first. The coefficient for x in the first equation is 3. The coefficient for x in the second equation is number 2. If I would add the two equations, I would get more x. I would get 5x. If I would subtract the two equations, I would still be left with 1x. It wouldn't eliminate it completely. Let's look now at y. The coefficient for y is positive 2, and the coefficient for y in that second equation is negative 2. If I would add the two equations, I would get positive 2y plus negative 2y, which is a 0. And effectively, I eliminate that y variable. So let's see what happens. What I want you to do is draw a line under the two equations and a big plus sign beside them, because that indicates what operation, mathematical operation, we're going to apply to eliminate one of the variables. So let's see what we are left with. We have 3x plus 2x equals, since we've eliminated the y's, equals 9 plus 16. Now, all we have to do is simplify and solve for that x variable. So 3x plus 2x equals 5x on the left-hand side, and 9 plus 16 equals 25 on the right-hand side. In order to isolate x, we have to divide both sides by 5, and we are left with x equals 5, positive 5. We are almost there. And I know you're going to say, wow, that looks so much simpler than substitution. I know. Some of you will prefer elimination over substitution. But I still want you to think of substitution right now. Now that I know my first variable, which is x equals 5, how can I find that second variable? Well, I can find it by substituting x equals 5 in one of the two equations. And unlike substitution, it does not matter which equation we're choosing. However, I want you to think of the sign of the coefficient for that y variable. And we know that it's always easier to isolate a y that has a positive in front of it rather than a y that has a negative in front of it, and then you have to manipulate the whole equation to properly isolate y. So I am going to choose equation number 1 to isolate that y. So I have 3 times 5, because instead of x now we're substituting and we're using 5. So 3 times 5 plus 2y equals 9. Just like we had above, we have to simplify and solve for the y variable. 3 times 5 is 15, and I have to eliminate it from the left-hand side to properly isolate y. So I have 2y equals 9 minus 15 gives me negative 6. Now we're going to divide both sides by 2, and we will have y equals negative 3. Now you have found that point of intersection for the two equations, for the two lines, which has the coordinates 5 and negative 3. Thank you, and please move on to example number 2 on your worksheet. And also you have a variety of systems of equations in your textbook.